There, I can do it anyway. So notice how over here, already I don't have abstract multiplication, so I'm not writing this down as if I'm doing an abstract multiplication problem. So it's not work to help me abstract on paper, but it is work to work on mental math. And that's why it's a group process, because 9-year-olds are no longer into that individual thing. We're working on building group cooperation. And it's a great thing to play in the fall because they're reminding each other of the facts. All right.
What's the game called again?
The bank game, or the bankers game, or I've heard you call it the big bankers game. So lots of, we just call it the bank game. 6 times 3 is 18, 18 thousands. She can do this one because you get 10,000 and 8,000. Great. And there, again, this is why I'd have everything slid over as far as I can, because I'd want to try to fit that 10,000 into its place. And what I would then do is I would have to get at least a first partial product. You can't get a second partial product, but I can exchange to get an actual first partial product. I'll keep the 2. I'll exchange these for a 60. And then I can keep the 200. We want to exchange this for a 10,000.
Well, shoot, we don't have a 10,000.
Right, so now I have to jump right away and say I'm going to give all of this and please give me a 20,000. Exactly. And then it's fun again to make magic, so I can put that down and make magic with my first partial product.
Wait.
Okay. Alright, so make magic. I make magic by putting the digits on top of each other and then sliding.
Woo, that's cool.
So there's my first partial product. I could write it down if I want to. I'm going to flip these back upright because I'm going to use them again. But I'm going to turn the 3 over because I'm done with the unit. And now everything gets multiplied by 40. So here's the fun fact. Now, you don't have to worry too much about the placement on this, but I wanted to at least do this, and I know it's noon right now. If you're all right for another 5 minutes, because I want you to see what happens to the 0. Because it will show back up again at the second half of the summer when we start working with decimal numbers. Okay? So it's very short. We didn't memorize our 40 facts,
No.
but we've worked with magic zeros before. What can I do with that 0? I can move it over to here and watch what happens, and I make noises.
Now that's definitely going on
Look,
YouTube.
it turned 4 into 40. I see the 50 underneath it, even though the color didn't change, I see where the 0 is, so I have that idea of it exchanging. And then I'm multiplying now by a unit, and I move that over. Now, not a big deal right now for us as adults seeing that happen, but it is going to be a big deal when we start working with decimals and realizing what happens when we're trying to multiply something less than 1. It doesn't have 0 then. So just keep that's all I wanted to do, is make sure that stays in your mind. And now I can do 4 times 4 is 16, but I need 16 tens. So I need 60 and 100. Can. Yeah, so why doesn't she give me a 20 and a 40? Or, and you can set a rule, sometimes they come and ask me, Joel, are we allowed to dig back into our first partial product? Yeah, they can dig back into it, but because there's no way they're actually going to get an answer that for the second partial product, it may not actually be correct if they dig into it, but their final product will be. So, all right, so here we go. To do this, I would do all my backwards noises and move everything down again, because it's important to get the 0 back there again. Yep. And now I've got 500 times 4, so I need 20 hundreds, which would actually be 2,000, right? And then, again, everything would snap back into place. The snapping into place is so that I can move everything down and move the 0 properly to push it over. And now I have 700 times, or 7,000 times 4 means I need 28,000. Give me that, that's great. And notice how everything has to be shifted way over now. I try to keep it in the place value at least, so that I have these are going to shift these as well. You notice I'm dealing with this equal sign. I don't always need the equal sign in the banking in the way it's played here, and the kids sometimes will not use the equal sign. But I use the equal sign again when I work with the decimals. It helps me keep the place. The time symbol and the equal sign helps me keep things in the right place values when I'm pushing the 0 back and forth because of where the 0 ends up when we do the decimal part. All right, that pops back into place. This one's going to get shifted over one place. And my last fact is 60,000 times 4. So I need 24 10,000s. 240,000. She can't give me the.
She can.
Nope, that would be 2 million. I need 240,000. She
Here.
give me the 40,000. And I can give her the 2,000, and she'll give me 4,000 in this place, 400,000 in this place. Right? Or any other combination that the group agrees on. That's why, and again, those are really placed in the right places. These should be underneath each other. There we go. Now I can actually exchange. And with the exchange, in the exchanging, I end up having to use the first partial product in the exchanging, or else I won't have any of the right cards often. So I'll pull this back out again, so I can go all the way down. I've got 20 and 40 are 60, plus the other 60 makes 120. So I'm going to give you this, and I want, but I'm going to keep the 20. And get 100 from you. You can't give me 100, so I'm going to give her another 100 and this. So I really need
400.
I have no other thousands, so they stay where they are. I've got 8, 4, and 2, so I need 12. I need 12 of those. I'll keep that 2 there, right? No, I need
14.
14. I'm sorry. I'll keep that 4 there. And I'll get one more
100
of those, and then I'm going to exchange them anyway, so I might as well just get the 500,000.
Sweet.
Okay? And you guys are really sharp with your mental math. And then I can pull it all together into Magic, putting the problem back together the right way, and this is where the recorder would finally get to really write something back in the book. Really, like I said, all they're doing is they're writing the original problem down.
I gotta
the
practice
final
that.
answer. Put the original problem back together again. You can actually make it with materials. We had the 40 and the 3 can go back together again. It's the slant.
Just jacking it up.
It's the slant. There you go.
Let's just say it on video. 5,424,200. Oh, no, what was it?
It sounds like